So this was chapter 24, problem number 33. And what I'm going to try to do is record side to side solving problem number 35 as well. Chapter 24, number 35. Because they both use the same exact picture and the same exact kind of approach, right? We have an inner sphere that has a radius of A. Am I drawing this right? And then we have an outer shell that's radius B. And we want to know electric fields in all these different regions. We want to know the electric field inside of A. We want to know the electric field between A and B. We want to know the electric field outside of everything. Yep, and we want to know that for problem number 33 and problem number 35. In problem number 33, they give us the charge in a specific way. How do they give us the charge? What do they give us for charge? They give us rho. And rho is a charge over volume. And then in problem number 35, they give us that there's a total charge Q. They just flat out give us charge Q spread out throughout this whole shell. Okay? So the difference between these two problems is how they give you the charge. Problem 33 is a little bit easier because it's a little bit easier to scale the charge in that one. So in part A, we want to know what is the electric field on the inside of this. Yep. We can use Gauss's law. Integral of E dot dA equals Q in over epsilon naught. That's fine. How much charge is enclosed inside of that shaded in red area that I made?
0.
There's no charge. So I plug in 0. Integral of E dot dA equals 0 over epsilon naught. So E equals 0. Yeah?
Yes.
And I do the same thing in part A for problem number 35. Integral of E dot dA equals Q in over epsilon naught. Q inside is 0, so E has to be equal to 0. I got the same exact answer in part A for both of those problems. Any questions on that? Yes. So if I look at this picture that I have, all of the charge is in this shell. So if I'm inside of that shell, if I'm in this part, there's no Q's inside of there. So if there's no Q's inside of there, Q is 0. Okay. Any other questions on that? No? All right. So let's make some make some space. Let's do in the blue kind of region. So I'm kind of shading that in for you. That's the blue part where the charge is. It's in between A and B. I need to know the electric field. So for part B, electric field if R is greater than A but less than B. Integral of E dot dA equals Q inside over epsilon naught. Same thing for part B in number 35. Integral of E dot dA equals Q in over epsilon naught. Yeah? Okay. Left-hand side. What do I get on the left-hand side? E times the integral of the surface area of a sphere. 4 pi r squared. Because I am drawing a little Gaussian surface. That Gaussian surface has a radius of little r. So I get the same thing in both B's on 33 and 35. Now the hard part becomes finding Q inside. Q that is enclosed. In number 33, it's actually a little bit easier. I know rho is equal to Q divided by V. Rho is how the charge is spread evenly throughout this volume. So if I want the charge that's enclosed inside of this space, I can find rho inside is going to be Q inside times V inside. Rho inside is uniform, so it doesn't change no matter where I am. So rho is just rho equals Q in, which is what I want to find, divided by the volume that's enclosed inside of here. The volume enclosed is just this shell, this blue shell. So what's the volume of the blue shell? How big is this? What's the outer wall? How far? Let's just give me the radius from the middle to this outer wall. It's just R. So I want to know the volume of that. That's going to be 4/3 times pi times little r cubed. That's the outer shell. Yeah? So that would include everything. That's if I just had a big sphere. But I don't have anything in the middle of this, do I? So I need to take that volume out. There's no charge in there, so I need to subtract that out. How do I subtract that out? I need to subtract out that volume. Minus 4/3 pi times a cubed. Yeah. So then I can multiply this over to be next to my rho. I need to get my charge in terms of rho because I was given the charge in terms of rho. So Q in is equal to rho times 4/3 pi little r cubed minus 4/3 pi times little a cubed. So my E is equal to rho times 4/3 pi r cubed minus 4/3 pi little a cubed divided by 4 pi epsilon naught little r squared. We have questions on that? So now let's do part B of problem number 35. We're going to follow the same procedure. We have to find Q in. We have to find what is this charge. Okay. So charge enclosed is still going to be inside of this same space. Inside of that blue sphere. With that little radius R. Except here, I was given the charge in terms of Q. I was given the total charge. I wasn't given how that charge is spread out. So I have to figure out how that charge is spread out myself. I have to take a ratio of that charge. I have to scale that charge down to get just the charge that's included inside of my actual surface. So I have to take Q in. It's going to be equal to the total charge, which I was given, but then I have to scale it by the amount of volume that I'm taking up, divided by the total volume. So how much volume am I taking up? Where is that charge actually spread? Anybody? Same thing we did before. 4/3 times pi times r cubed minus 4/3 times pi times a cubed. But I have to do this scaling as a ratio. Yes. What do I have left? So I'm finding the Q that's inside has to be equal to a fraction of the total charge. So to get the fraction of the total charge, I'm going to multiply by volumes. The volume where the charge is divided by where the volume could be. Yes?
How do you know how to do that?
Because we've done this problem before. It's in the reading to kind of describe how to do that scaling. So just practice. So maybe after I write this, I'll write it a slightly different way to see if that helps anybody. I have to divide by the total volume that I have for this whole thing. So the total volume is 4/3 times pi times the outer wall of where the charge is minus 4/3 times pi times where the inner wall is. So another way that we can think about this is Q in, the ratio of Q in over Q total, which is what I'm given, is equal to the ratio of, it's not equal to, it's going to be proportional to, inversely proportional to the total volume V in over the total volume. Does this help anybody? Q in over the total charge is V in, the same ratio as the volume inside divided by the total volume. So then I take this, I solve this equation for Q in. Q in equals Q total, which is Q total, times the volume inside divided by the total volume. So it's using ratios. And because the charge Q, they tell us, is evenly spread out, we can use this ratio. We didn't need to do that in the previous problem because they gave us rho. Rho is much easier to scale. We did the scaling. We did rho equals Q times V. And we did the scaling by V inside in the previous one. Okay? That is the difference. So now I can find this electric field. Electric field is Q times 4/3 pi little r cubed minus 4/3 pi times little a cubed, all divided by 4/3 pi little b cubed minus 4/3 pi times little a cubed, and then all of that divided by 4 pi epsilon naught little r squared. You can leave it like that. That's fine with me. That is super messy. If you did this in any other physics class that was taught anywhere on this planet, they would smack you in the face. But that's fine with me. I can figure out what you do. Okay. That's the difference between 33 and 35. 33, you do the scaling all with the rho. 35, you have to do this ratio scaling. Q in over Q total equals V in over V total. And solve for Q in. Questions on that? No? Okay. How do we do part C? Part C is the green part, where we're outside of everything.
Oh, you just changed the values to B minus A instead of R minus A.
Part C is pretty easy. Part C is you're enclosing all the charge, right?
Yes.
So you have E times 4 pi r squared. If I'm enclosing all the charge, that's Q over epsilon naught. E equals Q over 4 pi epsilon naught times r squared. That would be part C for problem number 35. And then 33, can we leave our charge in terms of Q in problem number 33? Or, yeah, in 33. In 33, they gave us rho, which is Q over the volume. So to find the total charge enclosed, I have to do Q equals rho times the total volume. Q equals rho times the total volume of where the charge is. Bless whoever that was. What is the total volume?
B cubed minus
4/3 pi times b cubed, where the charge actually is, divided by 4/3 pi times little a cubed. So I'm taking this and just doing the area where the charge actually is spread out. My Gaussian surface goes out all the way to this green. So why don't I include any of this? Why isn't it 4/3 pi r cubed?
There's no charge.
Because why?
There's no charge in that outside.
There's no charge in this outside part.
Charge is on the center.
If I'm doing rho, rho only refers to where the charge actually is. Rho is the charge density. Where'd it go? Right, so this is only where the charge is. So then I can use all of this to finally write my final answer. E times 4 pi r squared is Q enclosed rho times 4/3 times pi times b cubed minus 4/3 times pi times a cubed over epsilon naught, and then divide your 4 pi r squared over. There's your answer. So you have to do this in problem 33 because you're given rho. You have to get rho looking like Q. You have to solve for Q. In problem 35, we didn't have to do that because we were given Q. So that's the difference. 33, you have to scale both times in B and C. It's easy to scale. Problem 35, you only have to scale in part B. The scaling's a little more tricky in part B, but the rest of it's easy. Both are fair game for it. Or neither. Who knows? I don't know what I wrote the exam last week, or no, I wrote the exam this weekend. And I took it. It has answers. Yeah.
Can you post this on Canvas?
I can. I'm not going to. I don't think. Maybe I already did. Any other questions on this one? No? All right, let's keep going with this infinite whiteboard thingy. This is crazy. All right, I'm just playing with this now. Let's do problem number 24, chapter 24, number 61. So we've got some stuff here. Somebody read this problem for me.
A point charge Q1 is at the center of two conducting spherical shells. The larger shell has a total charge Q2 on it. The smaller shell has a 0 net charge. What is the charge on the inner surface of the smaller shell? What is the charge on the outer surface?
Oh yeah, they ask us tons of stuff in this, don't they?
Yeah.
Oh gosh, my answers won't come up, so I've got to work off book, off answers. So we got to come up with this off the top of our heads. I hope you know how to do this one. So we have a point charge at the middle. And how big is that point charge?
Q.
Plus Q. Plus Q, isn't it plus Q1?
Yes.
Yes.
1.
And then we have a bunch of empty space. And then we have a shell. So we have a shell of charge here. We'll make it a red, colorful candy shell. That shell has a total charge. What's the total charge of this shell?
0.
Q total equals 0 for that inner shell. And then we have another shell, don't we?
Yes.
We have another outer shell. Let's make that one blue. What's the total charge on the outer shell?
Q2.
Q total on the outer shell equals Q2. Now I have to start figuring out where charges, what charges are in what places and how big they are and all sorts of wonderful things. Let's move this a little out of the way. And let's start figuring this out. I first need to know what? The charge on the inner shell of the inner shell.
Of the smaller shell.
Okay. So I have Q, inner, small, equals something. Q on the inner surface of the small shell. So that's going to be right here. Inner surface of the small shell. To figure out what that is, I need to do Gauss's law. So I can do Gauss's law and I can figure out, okay, what is Gauss's law say if I were to draw my spherical surface inside of this conducting shell? So based on that green dotted line, if that's where I want to know my electric field, what does my electric field have to be there?
0.
Has to be 0. Why does it have to be 0? Because it says so. No. There's charge enclosed inside of there. I see a Q1 right there. What's the total electric field have to be inside of this conducting shell?
0.
0? Why does it have to be 0?
Because it's a conductor.
Conductors. Electric field inside of a conductor is 0. So inside of this conducting shell, I have to get 0. So to get 0, I need 0 charge enclosed. Right now I have positive Q1. I can't have any charge inside of the conductor. All the charge on the conductor exists at the surfaces. So I have to have charge on the inside shell of this, inside surface of this small shell. So the charge on the inside surface of the small shell has to cancel out the charge at the middle. So that I get 0 enclosed charge, so they get 0 electric field from Gauss's law. So I know I have to have negative Q1 on the inner shell of the small, inner surface of the small shell. So that's got to be negative Q1. Yeah?
Yes.
Okay, now let's go to the outer surface of that. Let's go to the, what should we call it? Q outer of the small shell. How much total charge do I have in the middle? Not in the middle, on this shell, on this small shell.
0.
Q total is 0. They gave us that. So if I have negative Q1 on the inner part of that small shell, what do I have to have on the outer part?
Positive Q1.
I have to have positive Q1 so that I add up to 0. So let's write this a little bit differently. Q total for the small shell has to be 0. Q total for the small shell is equal to Q inner from the small plus Q outer from the small. So Q outer from the small has to be Q total from the small minus Q inner from the small. I know that Q total small is 0, minus Q inner small is negative Q1, so Q outer small has to be equal to positive Q1. No?
Yes.
Okay. Any questions on that? No? It's going away. It's leaving. Okay, what's the next part? We have to find the electric field. Have to find the electric field in this region at a distance little r. So E times 4 pi r squared using Gauss's law equals Q in over epsilon naught. How much charge is enclosed inside of this? Let's add up all my charges. I've got a positive Q1 right at the middle, plus the amount of charge that's on the inner shell. How much charge is on the inner shell? Negative Q1. So that cancels out to 0. So I'm at 0 charge. And then I go to the outer shell of the inner, outer surface of the inner shell. That's positive Q. And then I reach my surface. So there's positive Q1 enclosed. So E equals Q1 over 4 pi epsilon naught times little r squared. There's my electric field. Next part. What's the next part? Next part wants the inner surface of the outer shell. Q inner of the large shell. What does that have to be equal to? Well, let's see. Same way we solved the previous inner shell, we come out here and we do Gauss's law. I need the electric field right inside of here to be equal to 0. Why does the electric field in this blue part need to be 0? Because it's a conductor. So how much charge do I need to enclose inside of this? For the electric field to be 0, how much charge has to be in there?
Well, isn't there a positive Q on the outside? So
I don't care about what's going on out here.
no, on the outside of the other, yeah, on that rib.
I care about interior to this. I need the total charge interior to this to be equal to 0.
Yeah, so it would be negative Q.
So I need to add up all the charges that I have. Yep. I need Q inner large plus Q outer small plus Q inner small plus Q1 to be equal to 0. Yeah? And I've solved all of these previously. Q inner large plus Q outer small. What was Q outer small? Q outer small is positive Q1 plus Q inner small. Q inner small is negative Q1 plus Q1 equals 0. That positive Q1 cancels with the negative Q1. And I end up with Q inner large plus Q1 has to be 0. So Q inner large has to be negative Q1. Okay? Bless you. Questions on that one? Preguntas? No preguntas. For those watching on YouTube, I don't really speak Spanish, so don't comment in Spanish in the video. I'll have no idea what you're saying. And good for you if you made it this far. This is 30 minutes. No other questions on that part. Okay, what's the last part? I think the last part. I hope the last part.
What is the electric field outside both cells?
Nope, not the last part. We want Q on the outer.
Oh my god.
This is not the last part. Q on the outer part of the large shell. So I want to know what's Q on this outer part. Let's draw it. An eye melting yellow. What's Q right there? So to figure out what that is, I need to know what's going on the outer shell. I know the total charge that has to be on the outer shell. I was given that at the very, very beginning. Q on the outer shell has to be equal to Q2. I also know that Q outer total has to be equal to Q outer. Oh wait, I've mixed up all the descriptions. So the large shell, I think we called it Q large. Total on Q large is Q2. We're given that at the very beginning. Q large is equal to Q large outer, which is what we're looking for, plus Q large inner. The two surfaces of the shell, inner and outer shell. Q large equals Q2, plug that in, equals Q large outer, what we're looking for, plus Q large inner. Q large inner we just found was negative Q1. So Q large outer has to be equal to Q2 plus Q1. Yeah? Okay, wonderful. Questions on that? Okay, last part. Find the electric field. Find the total electric field. E times 4 pi little r squared. We are now outside of this whole thing, outside of everything going on. I think I'm going to make people sick watching this video. I'm way out here. This is kind of trippy. Go to DC and buy some brownies.
Where's my acid? I don't know what that is.
Brownies are legal. Acid is not. So I have to be outside of this. So I have to include all the charges, right? To include the charges on all the shells and at the very, very middle. How much charge do I have on this shell? How much charge is enclosed on that whole shell? What's the total charge? Q2. That's the total charge on that whole shell. Q2. So I'm enclosing that whole shell. How much charge is on this inner shell? This one. What's the total charge? 0. How much charge is in the very, very middle? Q1. So how much total charge do I have enclosed? Q1 plus Q2. That's my enclosed charge. So my electric field should be E times 4 pi r squared equals Q1 plus Q2 over epsilon naught, and my E is Q1 plus Q2 over 4 pi epsilon naught little r squared. And that's problem number 61.
Box problem.
Yeah. Any questions on this?